Okay, folks, the distributive property, used all the time in algebra, and it's a good one for kids to know. I like to start, in class you may see me refer to cups and pennies because I use Dixie cups because they're cheap. Each Dixie cup has an X on it, and then I'll use pennies, right? I don't know. So a penny that's got Lincoln's head face up is worth positive 1, whatever. So you've got X plus 3. On paper, that would look like this, X plus 3, right? Okay. But the distributive property says this. It's not just X plus 3. It would look something like this where, right? And so what you would say is, just like you would read this as 2 times 5, well, you would read this as 2 times X plus 3. And what I tell students is there was a day back in the old Sturbridge Village days when nobody referred to this as 2 times 5, they would refer to this as, 5 2 times, right? Because, 5 once, 5 twice is 10, and 2 times 5 is 10. And so what we do here is we say, it's not 2 times X plus 3. I mean, it is, and that's how students should say it. But when you think of it as X plus 3 2 times. So going back to my cups and pennies, it's not X plus 3 once, it's X plus 3 2 times. And so when you have this thing done twice, that of course results in 2X plus 6, right? And so these two things are equivalent, and this is a result of the distributive property. We can go through another example. Oops, sorry, wrong examples. Here we go. Go through another example, go through 100 examples. We'll go through, we could make it even like 2x plus 1, right? 3 times. So you could say 3 times 2x plus 1. Well, algebraically, you could think, x, and 1 time, 2 times, 3 times, right? So that results in 1, 2, 3, 4, 5, 6 x's plus 1, 2, 3, 6x plus 3, right? And so this becomes 6x plus 3. Another example would be, 3n plus 4 5 times. Now, I saw a student do this once. I thought it was pretty cool. They had 3n plus 4 once, 3n plus 4 twice, 3n plus 4 3 times, 3n plus 4 4 times, 3n plus 4 5 times. And then they treated the whole thing like it was this giant addition problem, right? And so they said, well, 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20. So those all add up to 20. And then the n's, 3, 6, 9, 12, 15, gets you 15 n's. So the whole thing is equal to 15n plus 20. Now, for those of you, some of you have probably already seen the pattern. Distributive property works like this in a quicker way. We say, distribute, right? I think of distributing Valentines on Valentine's Day. Kids, in lower grades will distribute Valentines. They pass out the Valentines to everybody. And so to distribute, right, means to pass out. And so it's like the number that's outside the parentheses is being distributed. 2 times x results in 2x, and 2 times 3 results in 6. And so, right, that's where you get your 2x plus 6. Going back here, right, 3 times 2x is 6x, and 3 times 1 is 3. So the whole thing is 6x plus 3. Going back to this example, 5 times 3n is 15n, and 5 times 4 is 20. So for some students, that's just a quicker way to use the distributive property. Any other good examples? I mean, it works with subtraction too. You could do something like this, where, 8n minus 2 3 times. Well, I would do 3 times 8n is equal to 24n minus 3 times 2 is 6, so it would end up as being 24n minus 6. Yeah, I think that's basically it. Okay.